Hi guys, so today we're doing Unit 8, Lesson 12. We're comparing data. So we're drawing conclusions about two or more box and whisker plots because that's kind of what they're going to ask you to do on the EOG. So when you're doing the EOG this year, they're not going to just show you one box and whisker plot. They'll probably show you two, and they're going to ask you to determine what you know. And that you can find the difference between the 5 parts of a box and whisker plot, and that you can determine the meaning between the different parts of two box and whisker plots. So let's just dive in. Some of these questions look really wordy and it's more ELA than math, but that's okay because we're going to use a system to figure it out. So it says the box and whisker plot shows the distribution of test scores for 2 students for a semester. So if I look at Jim's scores, I can see that he has everything from a 72 to a 90, and I can see, and I'm just guessing. I'm looking at it and I'm going, okay. Well, hang on. Maybe I can guess a little closer. 72, 74, 76. Yeah, it is a 72 to a 90. And Sarah goes anywhere from a 82, 84, 86, 87 to a 100. So this is Sarah and this is Jim. So now I have to decide which one is true. Overall, Jim has better grades than Sarah. Jim had more consistent grades. Well, Jim's spread is really far, and he scores everything from a 72 to a 90, whereas she is a B to an A student. So I'm going to cross out A. B, overall, Jim had better grades than Sarah, but Sarah had more consistent grades. Well, remember, the smaller the spread, the more consistent your information. So Jim's spread is what? 28? Because I'm doing 90 minus 72 and I get 28. And Sarah's is 13. So Sarah is definitely more consistent with her grades. So I'm going to cross that out. Overall, Sarah had better grades than Jim. So that's a check. Sarah had more consistent grades. That's also a check because her grades are closer together. Okay, so her grades, her spread is a lot smaller. So when I subtract the largest number and the smallest number, her grades are a lot closer together. Overall, Sarah had better grades than Jim. That's a check, but Jim had more consistent grades. Well, there's a 28-point spread on Jim and only a 13. So I'm going to go with C. So this is a lot of ELA, where you're just reading through and kind of making a determination. So how much greater is the interquartile range of the women's ages than that of the men's? Well, if you remember interquartile range, we're talking about the box. So we have 30 and 38 on the men. So the interquartile range would be 8 because I'm doing 38 minus 30. The women, it's 22. Oh, wait, I pulled the wrong point. I'm looking at the box. So it should be 26 and 36. So this one is 10. Okay, so how much greater is the interquartile range of the women's ages than that of the men's? Well, oops, sorry guys. That's 10 and that's 8, so it would be 2. How much greater? 2. All right, what is the interquartile range of the wait times at Gary's Grill? So they're giving me 2 box and whisker plots, but I don't need both of them. Lucy's Steakhouse is useless to me. So we're talking about the interquartile range. So we're talking about the box. So I'm doing 20 minus 10, and I get 10. So what is the interquartile range? 10. So even though they're showing me 2 boxes here, I don't need them both. Now they're showing me 3 boxes. Great. Which statement is true? Okay, so I'm looking at the interquartile range. Okay. So it says has the largest interquartile range. So it's going to have the biggest box. So 1976 to 1985. Yes, I would say they have the largest interquartile range. Let's check the median. Remember, the median is going to be that center line. Oops, that's not thin enough. I'm just going to switch colors then. Okay, so the median is that line in the middle. So what this one's about 5.5, this one's about 4, this one must be about 3.5, and this one is about 7, between 6 and 7. I'm eyeballing it. So does 1966 to 1975 have the largest median? Well, no, that's not true. Okay, the thing with a box and whisker plot is it has nothing to do with means. It has nothing to do with averages. So I don't know if they have the largest mean. I can't figure that out. 1996 to 2005 has the largest range. Well, remember, range is where I'm subtracting the largest and the smallest. So when I look at range, I'm looking at the ends of the whiskers. So the largest range is going to be either one of these two, because these two have their whiskers aren't very far. So it would be this one, so that's also not true. So it has to be A. What is the measure of the interquartile range of the dot plot? Now this is going to be where it gets challenging. So I have to list out my data first. So I have 10, I have 2 12s, 2 14s, and I want to write neatly. 2 16s, 2 18s, and some of you can just use the dots, and that's okay. I want to make sure that I'm exactly right. So before I do anything, I'm going to check to make sure I have all the numbers. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I have 16, so now I'm going to count the dots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, it checks. So I always check before I do anything, because if I'm off or I wrote it down wrong, I'm going to be screwed up for the whole thing. So remember, interquartile range is where I cross out and I find that median first. So I'm crossing each side until I find that middle number. So I have 2 numbers in the middle. So 16 plus 18 is going to give me 34. And I'm going to divide that by 2 and I'm going to get 17. So the median is 17. So now I'm going to find the median of the lower half and the median of the upper half. So I have 2 numbers in the middle again. So 24 plus 24 divided by 2 is going to leave me with 24. So my Q3 is 24. Now I'm going to do my Q1. So I have 14 plus 14, I get 28 divided by 2. That's going to leave me with 14. So remember, I'm doing Q3 minus Q1. So I'm doing 24 minus 14, and I get 10. So the interquartile range of my data is 10. Now, if I want to cross out the dots, I can, but I have to be really, really careful when I'm doing that. There's got to be a lot of organization. All right, so based on the graphs, which statement is true? Okay, the boys have a lower median and interquartile range than the girls. Okay, so I have to find the median and the interquartile range of both. So for this one, I'm actually going to use the dots and kind of show you how I would do that. So I'm going to find the median. And I'm going to double check. So I have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So it's going to be 85 is my median. Okay, so I check to make sure that I have the right number of dots in front and behind. So then I'm going to go, and that would be 81, 82, 83. And then 86 would be Q3. So then I have to check the other one. All right, so I used red before, so I'm going to use red again. So I have 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So it works out. So my median is going to be 85. My Q3 is 87. And my Q1 is going to be 85. Because I have 2 numbers in front and 2 numbers behind. If I don't like this strategy, I can list them out just like I did in the last problem. So the medians are the same, and my interquartile range, or my IQR in the first one, is 86 minus 83, and I get 3. And in this one, it's 87 minus 85, and I get 2. So now I can answer the questions. It says, the boys have a lower median. No. The boys have a higher median. No. The girls have a lower interquartile range. No. The girls have a higher interquartile range. I think it's this one, but I need to check the second part. But a lower mean. So remember, with mean, you have to add up the numbers and divide by how many numbers you have. So this is where I'm going to get out my calculator and I'm going to check. So in my calculator, I'm adding 80 plus, 82, 83, 2 84s, 2 85s, 2 86s, an 87, and an 88. And I get 930. Then I'm going to add, and then I have to divide by the 11 because there were 11 students. And I get 84.5. So now I'm going to add up the boys. So I have 84 plus 84 plus 4 85s plus an 86, another 86, an 87, an 88, and a 90. And I get 945, and I'm dividing that by 11. So I get 85. So they have a lower mean than the boys? Yes, that is definitely true. So D should have been my answer for that one. All right, for the next one, they want the mean, the difference between the means. So remember, mean is when I add up all the numbers and divide by how many numbers there are. So the best strategy I can tell you for this is to kind of count it up. So I have 3 ones. I have 1, 2, 2, 4, 6, 8, 10, 12, plus 12, plus 9. And each of these dots is 4, so that's 8, 5, and a 6. And then an 11. So I added them all up, and then I'm going to divide by the number of dots. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So I'm going to divide by 17. I'm going to double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Yep. So I'm going to add up all these numbers and divide by 17. So the reason I didn't add them up individually is because it's more likely that I'm going to make a mistake. And I know my own math ability. So I got 54 when I added them all up. And I'm dividing that by 17. And I got 3.176. And I'm going to stop there. All right, then, oops. Then I'm going to do the other one. So for this one, I have a 0, 3, and then each of these dots is 2, so that's 6, 9, 8, a 5, and a 6. So I'm going to add up those numbers. 3 plus and I get 37. And I'm dividing that by the number of dots. So even though there's a dot on 0, I still have to count it. So that's 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So I'm dividing by 14 this time. And I get 2.642. So then I have to figure out, okay, the team's mean. So team 1's mean is greater. So I know it can't be B because that says year 2 is greater. That one also says year 2 is greater. So now I have to decide how much greater. So I'm going to subtract 3.176 minus 2.642. So I get 0.534, so I know it has to be C. All right. The last one we're going to talk about is how much higher is the median score than Sarah's median score. So remember with medians, I have to put the numbers in order first. So I'm going to start by putting the numbers in order. And then I'm going to cross them out on each side. And then I'm going to do Kylie's. So again, I'm going to cross them out on each side. How much higher is Kylie's median score than Sarah's? Well, 114 minus 112 is 2. So B. So now you're going to go ahead and do your cool down. So I'm giving you 2 box and whisker plots. I want to know how much greater is the range of the test scores for first period than second period. So remember, range, you're subtracting your minimum and your maximum. So I want to know what's the difference between the two. So you need to find the range of the first period, find the range of the second period, and then subtract them. All right, have a great rest of your day.